Hey guys, welcome back to Chemchris online class. Let's focus on reacting mass and reacting volume. We are seeing what JAMB 2024 Chemistry online class. Now, this class is not only meant for the JAMB students, but also meant for what? For those guys who have just gained admission into any of the higher institution and you are doing chemistry. So, if you are doing chemistry in what any of the higher institution, then this video is for you because you're still going to learn this topic. Do you understand? So now this topic are proved to be one of the most difficult topic when it comes to calculation in what in chemistry, when it comes to what reactive mass and what reactive volume. So I want to watch take time to dissect everything for you now for you to understand. And questions we always solve in this class or in this video, you have to see them in the exam. So make sure you pay close attention because I want to give you the mysteries and give you what secret on how to solve problem under 1 minute. You are able to solve problem if you can master what I'm going to teach you in this class. So if you are ready for this class, leave a comment section that I am ready for the class. Leave a comment section. I am ready for the class. And make sure you have your notebook, your calculator, and your pen. You get. And make sure you are in a place where nobody is going to distract you because this class needs high concentration. If you are ready, leave a comment section that I am ready for the class so I can start moving on. Do you understand? And for those of you, before we continue, for those of you who have not joined our private online class, you are missing a lot. You are missing a lot because in our private online class, we learn maths, chemistry, and physics. And we also conduct mock examination every single week. Do you understand? So if you have not joined the online class, please endeavor to join the online class, especially if you are doing maths, chemistry, and physics. How much is the fee? The fee is 15,000 naira to join the online class. You are learning on the what on the consistent basis. So I will not just wait. Anytime I upload video here, you watch, you can be joining the online class on the what consistent basis. So if you want to be part of the online class, leave a message that I want to be part of the online class. Then I will tell you what to do. You make payment, you join the class, and join your other colleagues that are always start learning. So let's get into it. So now, how do you solve reacting masses? Now, there are different ways you can solve reacting masses. There are different methods, but I'm going to show you one of the simplest ways that can be of help to you. Imagine here we have H2 plus or O2 give you what? H2O. Because it's called is what reacting masses, you have to what write out what a balanced chemical equation. This is what hydrogen. You have to what write out what a balanced chemical what equation. So hydrogen gas you have what oxygen gas to create what water. Do you understand? So you have to what balance the equation. Do you get that? So if you don't have to balance chemical equation, then now you like message that I don't know how to balance chemical equation and I want you to do video on that. If I see enough comment on that, my next video I want to produce videos on that what balance chemical what equation. So if you don't know how to balance chemical equation, leave a message that I don't know how to balance chemical equation and I want you to what create video on that. So that I will know exactly what to do. So now let's balance this equation here. So here we have 2, here we have what 2. So okay, this is called a special method. The special what method? 2 molecule of hydrogen get what one molecule of oxygen to go or 2 molecule of water. Do you understand? So how many oxygen do you have here? Here we have 4. How many hydrogen do you have here? Here we have 4 hydrogen. Here we have 4 hydrogen. 2 oxygen. Here we have 2 oxygen. So you must balance what a chemical equation. You must balance what a chemical equation. Now, it's a question. The balance equation will be given to you. Why it's a question? It's not what will be given to you. Like what I'm going to show you as we move on. Do you understand? So imagine you are working with what this balanced chemical equation. How do you go about solving reacting masses? Now you must take note of this thing I'm going to explain to you now. So you want to write what the balanced mole, the balanced mass, and the balanced what volume. These 3 key things are very, very important. Do you understand? So what is balanced mole? What is balanced mass? I want to put balanced what volume for each of this here. So here you can put state gas, and what and gas. Do you understand? So therefore now let's get what the mole, right? The mole is just what the coefficients. How many moles do we have here? Here we have 2 moles, right? 2 moles, right? How many moles do you have here? Here we have what 1 mole. How many moles do you have here? Here we have what 2 moles, right? Do you understand? Now, how do you get the mass and volume? It's very easy. Therefore, let's calculate the molar mass of each of these compound here. So, if for example here we have H2, O2, H2O, right? Now, what is the atomic mass of hydrogen? Atomic mass of hydrogen is what is 1. 1 times 2. Please, where is this 2 coming from? Here we have 2 molecules of what? Hydrogen. So the atomic mass times the mass of atom, right? Going to be what? 2 gram per what? Per mole. Do you understand? What about here? Oxygen is 16. The atomic mass is 16, right? Times 2, 16 times 2. Here we have what? 30 what? 2 what? Gram, right? So what about from here? Here we have 1 times 2 plus what? 16 times 1, right? Could be what? 80 gram per what? Per mole. Please pay close attention here. So here we have what? 18. Here we have what? 18. So now we are going to use us here to get what? The balance what? Mass, right? Now whenever you see something like this, 2 gram per mole, what does it mean? It means for every 1 mole of what? H2, I have what? 2 gram of what? Of H2. That is meaning. Do you understand? Yeah, this is 2 gram per mole. Yeah. So here it's supposed to be per mole, right? For here it's going to be what? For every 1 mole of what? Of O2, I have what? 32 gram of what? O2. Do you understand? And for every 1 mole of what? H2O, I have what? 18 gram of what? H2O. Do you understand? So this is what we are going to what? Make use of here. So yeah, how many moles do you have? How many moles of hydrogen do you have here? Here we have 2. So to get the mass, that would be 2 times 2. 2 gram times 2. Because for every 1 mole of H2, I have what? 2 grams. So here is already 2. So it will be 2 times 2, which is what? 4. 4 what? Gram. Right? Oxygen, here is only 1 mole. So 1 times 32 is what? Is 30 what? 32 what? Gram. Do you understand? Therefore, for water, how many do you have here? 2. So 2 times 18. 2 times 18 is what? Is 30 what? 36 what? Gram. Do you understand? As easy as that. Now the next one to do is to what? Get what? The volume. And this volume is going to be what? At STP. So now when we ask me a question, volume at STP, this is what I'm talking about here. And volume at STP is always equals what? 2.4 dm cube, or what? 22400 cm cube. Do you understand? So when they measure at STP, this one should come to your mind. That dm cube or what? C cube. Do you understand? Now, and for this year, for every 1 mole of a gas, of a what? Gas, is equal to what? 2.4 dm cube of that gas. I there. Or 1 mole of a gas is equal to what? 22400 cm cube of that gas. Do you understand? So it's very important here. So the volume here, you are using what? This one here. Do you understand? So 1 mole of any gas is always equal to what? 2.4 dm cube of that gas. You understand? Or 22400 cm cube of that gas. Do you understand? So how many moles do you have? Here we have 2 moles, right? So 2 times 2.4 dm cube. Here we have 4.8 what? Dm cube. Do you understand? So how many moles do you have? Here we have what? 1, right? 1 mole. 1 times 2.4. Here we have what? 2.4 dm cube. Do you understand? Then here we have for water here. So 2 times 2.4. Here we have 4.48 dm cube. Do you understand? So this is the first thing you have to do when you are solving what? Reacting mass and what? Reacting what? Volume. Now, if you can get this one here, you have solved. If you can get this one here, you have solved what? Almost 70% of the question. Do you understand? If you can this one here, you have solved what? Almost 70% of the question. As easy as that. So now let's start solving some key questions you are going to see in the exam. Now let's start, because we have to solve like close to 5, 6, 7, or 8, 9 questions based on this, because I really want you to master the concept. Do you understand? So if you understood what I've just done here, leave my comment section that you are following and you understand what I've just done here. Do you understand? So let's move to practice problem. Now let's look at the first question, and this question here is going to explain so many things to you. So please pay close attention. So they said calculate the mass of iron that will be produced from 10 gram of iron 3 oxide from the what reaction. Now look at the reaction here. So now what we want to do here is to what do exactly what I say you should do. So now here we have here we have Fe2O3, right? Plus what? 3CO2, right? Ah, okay, yeah, we remove this one here. So is monoxide. Then you have what? 2Fe plus what? 3CO2. Now, in general, before you can start solving this problem here, first of all, you have to write down what balance mole, balance mass, and we balance what volume. Do you understand? Very important. So how many more do you have here? How many more do you have here? Here we have what one mole. How many more do you have here? Here we have what three what moles. Here we have what two moles. Here we have what three what moles. Do you understand? Now, what about the mass? So we have to worry for the molar mass of each of the compounds. Just we have to look for the molar mass of what each of the compound. And here they have given us all these things here. They have given us all these things here. Iron was 55.9, carbon is what is 12.01, oxygen is 16. 1 mole of a gas is equal to what 2.4 dm or liter. It's plenty stated here. Do you understand? So let's look at what mass here. And remember this one is what? This one should be. This one is solid. This one is solid. Again, solid. This is solid here. So the mass, let's look calculate what the molar mass of this guy here. So molar mass of Fe2O3 is very easy. Iron is what is 55.9. So 55.9 times 2, right? Plus oxygen was 16 times what 3, right? So what will be the answer here? So bring your calculator. That's why I say what you should bring your calculator. 55.9 times 2 plus 16 times 3. So you have 159.8 what gram per mole. Of course, to get the mass, you have to multiply this one with what? With this gram, with this molar mass here you have got here. Like what I've teach the other time here, right? So to get the mass, you have to multiply the mole you get here with the what molar mass of the compound. So the molar mass is 159.8 times 1 is still going to be missing 159.8. Is okay, good. Now the next is what is CO, carbon monoxide. You got 12 times 1 plus what 16 times 1 going to be 12 plus 16. We have what 28 gram per mole, right? How many more do we have here? 3. So how many more do we have here? We have 3. So 28 times 3, right? 28 times 3, what do you have? 28 times 3, what do you have? Here we have 84 gram, right? 84 what gram. Now iron is what? Iron is what? Is already what? 55.9. 55.9 times 2. So 55.9 times 2. What are you going to get? Here I want to get 111.8 what gram. Do you understand? Now CO2. CO2 is what? 12 times 1 plus what? 16 times 2. Going to be what? 16 times 2 plus 12. Here we are what? 44 gram per mole. Do you understand? To get the mass, multiply by what? By 3. So 44 times 2, here we are what? 132 what gram. Please pay close attention here. Now, when it comes to the volume here, you don't have any business with what this guy and this guy because they are all is solid, gas and what and gas. It's okay. Pay close attention here. So please pay close attention here. So gas. So now let's get the volume. Let's get what the volume. So normally, if you don't want to look at if it's solid or solid here, normally if you want to go with it here, how many moles do you have here? One. So remember, for every 1 mole of any gas here, we have 2.4 dm cube. So here is not a gas, so you ignore it. Here is not a gas, what you ignore it. Do you understand? Because for every 1 mole of a gas here, we have 2.4 dm cube. They are not gas, they are solid, so you ignore it. Now these two are gases, right? So because here for every 1 mole of a gas, I have 2.4 dm cube. How many moles do you have here? You have 3. So 3 times 2.4. Do you understand? So you're going to be 2.4 times 3, right? 2.4 times 3 around 67.2 what dm cube. Do you understand? Same here. 67.2 what dm. Do you understand? So with this stuff here, I can answer my first one, second one, and third one easily. Do you understand? So how do I answer it easily? Please pay close attention here. I can answer it easily here. Now let's look at what the A. Let's solve the A now. You look at A, they say that calculate what the mass of iron. So we are looking for mass of iron. Mass of what iron? This is what you are looking for, right? Mass of iron, this is what you are looking for, right? Now they give us what mass of iron 3 oxide. Look at iron 3 oxide. So mass of what Fe2O3 is what 10 what gram. Do you understand? So once you have done this thing here, every other thing becomes easier for you. So yeah, mass of iron is do what I'm looking for. Mass of iron 3 oxide was given to me. Do you understand? So there is in the first question here, our point of focus is this guy and this guy. Right there. So now, but yeah, what did I say should look for? Mass. No, so you come to mass here. What is mass of iron here? Is what 118.8. 118.8, right? Gram. So it means that so because here we have iron first. So let's pick this one here. So iron, you talk about mass of ions. Yeah. What is mass of iron here? Is what 159.8 gram of what Fe2O3 is equal to. Now, because your point of focus is going to be this guy and this guy. Why you focus on this guy and this guy? Please pay attention here. Why you focus on this guy and this guy? One, because now they say you look for mass of iron, and we'll be giving you what mass of iron 3 oxide, right? So it's this guy and this guy. Now we are picking what mass and what mass. So 198.8 gram of iron 2 oxide, iron 3 oxide is equals to what 111.8 gram of what Fe. Do you understand? So this is what you're now going to use in your calculation, right? So there are 2 ways you can do this here. So remember, the mass of this one here was given to me to be what 10 gram of what Fe2O3, right? Equals to what? Do what I'm looking for S gram of what Fe. Do you understand? So just for you to do your normal cross multiply here, if you make sure formula here, when you cross multiply, what you have here, it's going to be S equals to now 111.8 times 10 over what 159.8. Do you see that? So what will that be the answer? Because you multiply it and what get your answer. So you have 111.8 times 10 divided by what 159.8. Here we have 6.99, right? Which approximately equals to what 7 gram of what 7 gram of iron, because I look for iron. 7 gram of what of iron. Can you see that? So this is what you use to get so here. Now let me explain it again because it's very, very crucial. Once you have done this thing here, you have solved almost 70% of your problem. So the goal here is, now whenever it's something like this, the goal here is to what? Make sure you get this stuff here. If you can get this stuff, it's very easy. Now from the question we are looking for A. From the question is that calculate what's the mass of iron, right? when the mass of iron 3 oxide was given to me to be 10. Do you see that? So what will happen here? Now this is what will happen here. Now from the balance mass, now the reason why we pick mass of iron 3 oxide is because we are talking about what mass. So I'm coming and pick what is mass of iron 3 oxide is what 159.8. So 159.8 gram of what iron 3 oxide is equals to here mass of iron which I'm looking for. Now I'm looking for now I'm going to get what my mass here 111.8 gram, right? Of what iron. Do you get? So that is this is equal to this. Remember, they gave me what the mass of this guy here is what is 10. So it's going to be under. So two of them will be under. Equals to what? This is what I'm looking for. S gram of what? Fe, right? So what I want to do here is to cross multiply. Know that this one will cancel out this guy, and this guy will cancel out this guy. When you cross multiply, it's going to be this times this divided by this one here. So the answer is what 7 gram of what iron gram. Do you understand? 7 gram of what iron. So that is going to be the first one. Look at something here. It's a little bit complicated now, but when you keep practicing, it's going to be more easier for you. Do you understand? So that is for the what? For the word A. Now let's look at what the P. Do you understand? Let's look at what the P. How do we calculate the P? Okay, how do we calculate the P? So let's calculate the P. Let's calculate what the P part. The B part. So how do we calculate the B part of this question? The B part of this question here. Now let's look at the B part again. So what volume of carbon monoxide at STP? So that they are asked to work volume of what carbon monoxide, volume of CO. That's what you are looking for. Is okay. Volume of what CO carbon monoxide. That's what you are looking for. Now and they gave us what mass of iron 3 oxide. So mass of what Fe2O3 is what is 200 gram. Look at something here. The first one is mass to mass. Now why is it mass to mass? The first A is what is mass to mass because essentially look for the mass of what iron and they give us mass of what iron 3 oxide. So it's mass to what relationship. But this one here is not mass to mass relationship, is what? It's volume to mass what relationship. Volume to what mass what relationship. So now look at something here. Iron, they also give us what 200 grams. So we also look at what the gram right here. Right? Please pay close attention here. It's very easy. Pay close attention here. Now, we're also using what mass. Now, this is what is the given mass. But now let's take what our balanced mass. Right here. So mass of what iron 3 oxide here is what is 159.8, right? 159.8. So going to be this guy, and carbon monoxide is what is this guy here, right? So here we're talking about volume. Look at volume here. What is volume of carbon monoxide? Is this guy. Do you understand? So it's going to be this equals to what this. Now let me explain it again. From the question, you know your relationship. Do you understand? From the question, you know your relationship. Now, if you look at the question here, it says what volume of carbon monoxide at STP. You understand? So we are looking at what volume of carbon monoxide. So if you check very well, mass of Fe2O3 is this one here. So it's going to be 159.8 gram of what Fe2O3 is equals to here. Now they're talking about volume of O2. Now what is volume of O2 here is what? It's 67.2 dm³ of what? Of CO, right? CO. Do you understand? So from here now, yeah, this one was given to me, which is going to be what? 200 gram of what? Fe2O3 is equals to what? Here you go to be what? S dm³, right? S dm³ of what? Of CO. If you check very well, this one cancel out this guy here, right? And this one cancel out this one here. So you are making S formula here. So if you make Excel formula here, this times this divided by this times, right? So if you make Excel formula here, so you're going to be X equals to 200 times what? 67.2 over what? 159.8. Do you understand? So what you want to do is you want to use your calculator. So if you use your calculator, here you have 200 times 67.2 divided by 159.8. dot 8. So we have 84. So we have 84.105 what dmq because it's volume. Because what is volume. So you can see how easy it is here. It's the same pattern, right? But here that the first one here is what mass to mass, but here is what volume to volume. No, volume to what to mass or mass to what to volume. So let out C. How do we calculate the C? How do we calculate the C? So it's still the same thing. You're still looking for what? Volume of what? Volume of what carbon monoxide, right? Volume of carbon monoxide. You're still looking for what? Volume of carbon monoxide. Now the mass of what iron trioxide is what 200, but they say what 90% pure. So to get what the mass of what Fe2O3 at 90% is going to be what 200 times what 90 over what 100. Do you understand? So you want to use your calculator to punch it. So what to be 200 times 90 divided by what 100. Here we have 180 grams. Okay, so the mass of iron trioxide that is now what 180 what gram. Do you get that? So that's what we want to do here. So it's going to follow the same pattern. So it's going to follow the same procedure here, right? So remember you are looking for what volume of what carbon monoxide, right? So what is the mass of carbon iron trioxide? Is what 159. 159.8 gram of what Fe2O3, right? Equals to now what is the volume of what CO here? Is what 67.2 dmq of what CO, right? Now they gave us what 180. So we calculated what weight, right? 180 gram of what Fe2O3 equals what SDMQ of what CO. Do you see that? And that this guy will cancel out this guy. This will cancel out this. If you make this one formula here, this times this divided by this, just so it's going to be x equals to what 180 times 67.2 over what 159.8. What is the answer? So you have 180 times 67.2 divided by 159.8. So you have 76.75 75.695 dmq. That is the what answer. That is the what answer. So, but we are still going to do more practice problem for you to understand. So, if you follow this video here, leave my comment section that follow this video here. If you don't understand, then you can ask your question, or you can go back and try to see how you can follow this video here. Now, you can still come back to this video and still rewatch this video for you to perfect it very well. Do you understand? But now, this is the simplest method I've ever seen in doing this kind of calculation. But now let's do some practice problem together. Now let me look at some other questions. This second question here, this is the typical JAMB question. This is what? So I can tell you that you likely see questions like this in the exam. Now look at the balanced chemical equation, just like the first question I explained. Say from the equation above, what is the mass of oxygen? I ask you what the mass of oxygen is needed to produce 15600 cm3 of steam. Steam is what? Water at STP. Do you understand? So now let's do exactly what I said you should do. So you have what? 2H2 gas plus what? O2 gas. You have 2H2O what? Gas. Are you there? So you have to do it fast. You have to do it fast. So you have mole, you have mass, you have what? Volume, right? So here we have 2 moles, here we have what 1 mole, here we have what 2 what mole, right? Now the molar mass of H2 is what 1 times 2, right? Which is what 2 gram per mole, right? Which I've already done before. So the molar mass of the gas times the mass of mole. right? So it would be 4 times 2. No, 2 times 2, which is what? Is 4 gram, right? Oxygen is 16. The molar mass of what? Of O2 is 16. Now the molar mass of what? O2 is 16 times 2, which is what? 32, right? How many more do we have here? We have what? One more. So 1 times 32. So it will be what? 32 what gram, right? The molar mass of water is 18 gram, right, per mole. So 18 gram per mole times 2 will be what? 36 what gram. Do you understand? So we have to do this one here. Then the volume, right? Now here they get the volume at STP is 2.4 dm cube. Is already given. The molar volume of gas at STP is 2.4 dm cube. So that is for every 1 mole of gas, 2.4 dm cube of that what? Of that gas. Do you understand? So please, how many moles do we have here? Here we have 2 moles. 2 times 2.4. We have 44.8 what dm cube, right? What am I saying here? This one is 1. 1 times 2.4. So it's going to be 2.4 dm cube. Here we have what? Here we have 44.8 what dm cube, right? Now, let's look at what they say for. What is the mass of oxygen? Mass of what? Oxygen. It's okay. Mass of oxygen. That's what they say you should look for. Now, volume. They give us volume of steam. They need to produce what? 5,600 volume of steam here, right? Now, remember, you have to convert this one to what? To dm cube. Now, whenever you convert cm cube to dm cube, you divide by 1,000. So I want to divide this by 1,000 here because there is dm cube, here is cm cube. Two of them must have the same units. So you must convert what? Cm cube to what? To dm cube. For every 1 dm cube, I have what? 1,000 what? Cm cube. Do you understand? So converting what? Cm cube to dm cube, you divide by what? 1,000. So if you divide it by 1,000, you divide it by 1,000, 5,600 divided by 1,000, you have 5.6 dm cube. So the volume of what? Of H2O is what? Is 5.6 what? dm cube. Do you understand? So this is what I'm looking for. This is what we are be giving here. So that is mass of O2 is what? So what is mass of O2? Mass of O2 is what? Is 32, right? From what? Balance what? For the balance equation here, right? So what is what? 32 gram of what? O2 equals to here, right? Now, do you know the reason why I pick this one here? Because they care about mass of O2. Although this is what I'm looking for, right? Equals to. Now, volume of H2O. So here we move to H2O. Here we have the volume here, right? We're going to be what? 44.8 dm cube of what? H2O. Do you understand? So remember, we are looking for what? We are looking for mass of what? O2. So here we can just say S gram. It's okay. So it's going to be S gram of what? O2 equals to what? The volume is what? 5.6 dm cube of what? H2O. Do you understand? So what I want to do here is to what? Ignore the. So this one can cancel out this guy. This one can cancel out this one here. So what you want to get here is what? Is 32 over what? X equals what? 44.8 or what? 50 what? 6 is okay. So the goal here is to make this guy a zero formula. So if you make this a zero formula here, what you're going to get is going to be X equals to this times this, right? 32 times 5.6 over what? 44.8, right? So bring out your calculator now. Bring your calculator and get your answer. So let me write this place out. So you know we're going to be 32 times 5.6 divided by what? 44.8. We have 4.0 gram. So the option is what? Is C. Yes, and the option is C. You get. Now let me just be sincere with you here. Now, at first, this thing may look so confusing to you until you start practicing questions. You get that? Especially if you are so new to this type of calculation here, it's a little bit complex. So what I want to do is to what? So have patience with yourself. Understand, tell yourself that you're going to understand this here because there's no way you're going to escape question from this type of question. It's not possible. as far as you're writing exam, you're going to see this question. You understand? So what you want to do here is to what, pay close attention. Then if I were you, I'm going to solve more problem after what this class. Now, but we still have a lot of problem to tackle. So let me do what question number what 3. Okay, now let's look at what the second question. Let's look at what the second question. And this is a typical JAMB question. Uh, this is called bicarbonate. When bicarbonate decompose, go to form sodium carbonate, CO2, and what water. Do you get that? So yeah, they are literally they have given us what the balance equation. So we don't need to worry about the balance what equation. All the questions we have solved so far, they have the balance equation. But time come when there are some questions that will not have balance what equation. So you have to what write the balance equation yourself before you can what solve everything. So but yeah, the balance equation have already been given to us. So yeah, how do we solve this here? So please pay close attention. It's that from the equation above, which is the equation here, calculate the mass of the residue formed. Now, this was the residue. Residue mean that what is a solid that is being deposited. It's from the product side, right? So you have solid, gas. So this is the residue that we're talking about. So whenever you hear residue, is what is a solid? Is a what? The solid. So when this bicarbonate, sodium bicarbonate is decomposed, and they're going to form a residue and what gas, CO2 and what H2. Do you get that? So what they want to calculate here is what is the mass of sodium carbonate produced if 1.68 gram of a bicarbonate is what decomposed. Do you understand? So here now, I'm not going to do everything here. I'm only going to look at these two things here. Now, instead of me to waste my time doing all that thing here, my focus is going to be on these 2 points. So it's going to be 2 NaHCO3 and what? Na2CO3. Is okay. So solid and what solid. Just that I don't have business with any of them here because the question is just streamlined on these 2 points. Just that. So in the exam, you don't need to focus on the rest things. Once you know the 2 species they are talking about, you just have to go ahead to solve the question. Do you understand? So now, there is saying about STP. So we are not talking about volume here. So what we want to do is to write the balance mole and what our mass So here we have 2 moles. Here we have what 1 mole, right? So let's look at what the mass. We have to worry for what the molar mass of this compound here. So we have NaHCO3 is equals to what? So it's going to be 23 times 1 plus what? 1 times 1 plus what? Here we have 12 times 1 plus 16 times 3. Is okay. So it's going to be what? 23 plus 1 plus 12 plus so we have calculator. So here we have 16 times 3, here we have 48. So when you sum it together, 23 plus 1 plus 12 plus 48, right? So here we have 84 gram per mole, right? So, but how many more do you have here? We have 2. So 2 times 48. Just so it's going to be 2 times 48. No, 2 times 84 is what? 168 gram, right? What about this one here? Na2CO3. Here we have what? 23 times 2 plus what? 12 times 1 plus what? 16 times 3, right? So it's going to be 23 times 2. Here we have 23 times 2. Here we have what? 40. Here we have 46 plus 12 plus 48. So what do you have here? 46 plus 12 plus 48. Here we have 106, right? Gram per mole. How many moles do you have here? We have what? 1 mole. So you're going to be 1 times 106. Here we have 106 what? Gram. Just so now, so if in a JAMB question you are being given something like this, Now you just have to look at what the two species given to you. What I'll be giving and what I want you are looking for, equate them together like this. Do you understand? So you have to solve it like this. From here now, why this place are because it's no longer needed. So now let's look at what they say to calculate. From the equation below, calculate the mass of the residual. So mass. So you look at mass of what sodium carbonate. This is what you're looking for, right? So let's say S gram. Do you understand? Now, the mass of sodium bicarbonate is being given to us. So mass of what NaHCO3 is going to be what 1.68 gram. Do you understand? So it's what the mass to mass, right? So it's going to be what 168 gram of what sodium bicarbonate is equals to what 106 gram of what sodium carbonate. Do you understand? So from here now, here we have the mass of this one given to me is what 1.68. So we have 1.68 gram of what NaHCO3 is equals to what S gram of what Na2CO2, right? So what I want to do here, I will come over to this place here. So this will cancel this guy here, and this will cancel this guy here. So what I have left is what 168, right? Over what 1.68 equals to 106 x. Making x formula here, right? I should make x formula here. X is going to be what 106 times what 1.68 over what 168, right? So let's get the answer. 106 times 1.68 divided by 168. Okay, so you have 1.06 watt gram. So there is the answer. So the answer is this guy here, right? So, but I'm not done with you because I don't want you to master this thing here. Based on the ways and pattern I've seen how they solve questions. So we have to look at the one that involve molarity so you understand it better. Question in this video here, they say that how many gram of hydrogen gas will be liberated when 6 gram of magnesium dissolve in 500 cm cube of 6 molarity HCl. You get. So from here now, if you take me the question here, they say that how many gram of hydrogen will be liberated, like be formed when magnesium metal react towards hydrogen chloride. You understand? So this question here, typically there was no equation given to us. Do you understand? So it means that you have to write a balanced chemical equation. Now, but before you write a balanced chemical equation, now let's write out all our parameters at first. So it's like how many grams? So they are looking for what mass of what hydrogen gas. I get that will be liberated. It's okay. Mass of hydrogen gas that will be liberated. You understand? So that's what they are looking for. That's what they say she will look for. Mass of hydrogen gas that will be liberated or that will be formed or produced when magnesium react with hydrogen chloride. So yeah, now volume of solution. Volume of solution is what is 500 what cm cube, right? Then molarity of what HCl is what is 6 molarity. You get. So how do we get the mass of this other one here? How do we get the mass? So that would be what the question. So now in saying that I need to look for the mass of hydrogen chloride. I need to look for the mass of hydrogen chloride. Please pay close attention here because here the mass or the volume was not given to us. You get. So the mass of HCl was not given to us. Now they gave us what volume 500 cm cube, not volume at STP. They didn't mention STP here. You understand? The volume is of what of HCl solution and the molarity. Do you get that? So what I want to do here is that I want to look for what mass of what hydrogen chloride. That's what I need to calculate. Mass of what hydrogen chloride. You get. So the question will be how can I calculate mass of hydrogen chloride using the volume and what and the molarity. Do you understand? So this way I'm not going to use a simple formula, right? So here, molarity is only equals to what? Mole over what? Volume. Mole over what? Volume. Is okay. And the volume is always what? dm cube. Right there. So now when we talk about molarity, because this is molarity here, the formula is what? Mole over what? Volume. Right? Mole over volume. Do you understand? Mole over what? Volume. And the volume is always what? dm cube. It means that for me to use formula here, I need to convert this one to what? To my what? I need to convert this one to what? To dm cube. Now, there's still another formula that said mass or what? Molar mass times what? Volume. Is okay. So I can either use mole equals to mole over what? Volume, or equals to what? Mass or what? Mass over molar mass times what? Volume. Now the volume must be what? dm cube. Do you understand? So if, for example, here, this now like I said, this volume must be what? dm cube. So how do you convert this volume to dm cube here? How do you convert this volume to dm cube? This dm cube to dm cube, how do you do that? You divide by what? 1000. Do you understand? So whenever you're converting cm cube to dm cube, you only divide by what? 1000. So when you divide it by 1000, what are you going to get? 0.5 what? dm cube. Do you understand? Hope you understand. So now, remember, I want to look for the mass of what? Molarity, right? I want to look for what? Mass of what? Molarity. So mass of what? HCl. I want to look for what? Mass of HCl. So I want to use this formula here. Molarity equals to what? Mass. But what? Molar mass times what? Volume. Do you see that? Molarity equals to what? Mass over molar mass times what? Volume. If I should make mass the solid formula here, what am I going to get? I'm going to have what? Mass equals to what? Molarity times what? Molar mass times what? Volume. It's okay. So this is what I'm going to use in what? In the calculation. It's okay. So I know what my molarity of HCl to be what? 6 molarity. Now I know my volume to be what? 0.5 what? dm cube. But what is my molar mass? How do I calculate molar mass? So I will calculate molar mass of HCl. Do you understand? So molar mass of what? Of HCl is equal to what? So it's going to be 1 times 1 plus what? 35.5 times 1 is okay. We're going to give what? 1 plus 35.5. We're going to do 36.5 gram per what? Per mole. Do you understand? So from here now I can easily what? Solve what? My mass. So I can see that mass of what? HCl is equals to what? Molarity, which is what? 6 times molar mass is what? 36.5 times volume, which is what? 0.5. Right? So if you punch your calculator here are what? 6 times 36.5 times 0.5, here we have what? 109.5 what? Gram. It's okay. So it is saying that now from the volume and the molarity, I'll be able to calculate what the mass of what? HCl. Do you understand? So this question is just like the ones we have done previously, but here they did not give us the mass straight. They only gave us the volume of HCl and molarity of HCl. So what you want to do here is what? Use that parameters to get what? The mass of HCl. So I can use to solve this guy here. And if this next formula I can use is what? Mass equals what? Molarity times molar mass times what? Volume. So this is the simplest formula here. Now you always see question under this in your exam. Yeah, you always see question under this in your exam. When you say calculate the molarity of a compound, when the mass, the volume is being given to you. So use what? This formula. Just now. So I want to write this everything. It means that I have achieved my first point here. So that is my mass of what? HCl is what? 109.5 what? Gram, right? Now, I'll write this place out because it's not needed again. So the next thing here, if you check the question here, if you check the question, the question was not given to us. Do you understand? Like the balance chemical equation is not was not given to us. It means that you are the one that will have to balance the chemical what you are the one that what you are the one that will write what the chemical equation and what to balance it. So now look at the question again. Now magnesium reacts towards hydrogen chloride. So that is Mg plus what HCl. Is okay. What happened here? Here is what solid. Here is what let me say gas, right? Okay, now when magnesium react with hydrogen chloride, what will be the product of the reaction? So that's why you need to learn how to predict the product of a chemical what reaction. In my picture video, I'm going to teach you how to predict the product of a chemical what reaction. I will not only teach you how to predict the product of a chemical reaction, I will also teach you how to balance that. And like what I said previously, when we start this class here, if you want me to produce video on how to balance chemical equation for you, leave like comment section that I need please produce video on balancing of chemical equation. Then that one will tell me that you really need that video. Then we'll produce that video for you. Okay, so how do we do that here? You have to what? Get the oxidation state. Now, what is the oxidation state of magnesium? The oxidation state of magnesium is what is Mg plus. I get Mg2 plus, yes. So that is magnesium. Now, whenever magnesium is reacting with anything here, it always loses 2 electrons. Do you understand? So here we have what Mg2 plus. Now here you have what if you split it here we have H plus now Cl what minus. Do you understand? So what we want to do here, we want to combine this guy and this guy. You get so positive you always attract what negative. Do you understand? Positive you always will attract negative. So when you are writing the ionic formula between positive and negative charge, so what are you going to get? You have Mg2 plus now Cl what minus. Two of them will combine together to what form a compound. Do you understand? So if you want to do that here, you have Mg, which is what is 2, this 2 here, then Cl, which is what is 1. Do you understand? So now, whenever you are reacting two things together, the first one you want to do is what know their oxidation state. So magnesium, the oxidation state is what Mg2 plus, because magnesium will always lose 2 electrons. Do you understand? So magnesium will always lose 2 electrons, the 2 atoms of electron. Then hydrogen chloride, when you dissociate it here, you have H plus now Cl what minus. Do you understand? So positive what you attract what negative. So that's what you have here. So if you want to write the any formula, this guy will move here, this guy will move here. So you have what MgCl2. Do you understand? So magnesium chloride. So this is one of the product MgCl2. Now this one I have not to combine with. You go to form plus what H2. Do you understand? So this is what is the gas. This should be gas. Then this was solid. Do you understand? But it does not really matter. Honestly, it does not really matter. Things that you should be able to solve the question. So this is what is a skeleton. You have created what the product of the reaction. The next you want to do is what? The next you want to do is to like balance the chemical equation here. Do you get that? So chlorine here is what is 2. You put 2 chlorine here. Yeah, so the question is what is balanced now. The question is what is balanced. Just and the question is what is balanced. So now when you balance the equation, so what are you going to do here? You get what are you going to do here? So this way you are now going to use what your mole and what and mass, right? Balance mole and what balance mass, right? How many moles do you have here? You have what 1 what mole. How many moles do you have here? You have 2 what mole. How many moles do you have here? You have what 1 mole. Here we have what 1 mole. Just 1 mole. So remember we are talking about what H2 and what HCl. Do you understand? So these are our 2 focal points. You get these are our 2 focal points, right? So the molar mass of HCl. What is molar mass of HCl? HCl. What is molar mass? Molar mass of HCl is what? Is 36.5 gram per watt per mole, right? H2 is what is 2 gram per watt per mole. Do you understand? So how many moles do you have here? We have 2 moles, right? 2 times 36.5. So here we have the balance mole the balance of mass. Now the reason why I did not focus on this guy and this guy here because HCl and what H2 that what my focal point. Do you understand? So the molar mass of HCl, the molar mass of HCl is what 36.5 gram per mole, right? So but how many moles do you have here? Here we have two. So 2 times 36.5. So let's do that. 2 times 36.5. Here we have 73. Here we have what? 73 gram. Do you understand? 73 what? Gram. Do you get? So yeah, how many more do you have here? How many more do you have here? Here we have one. 1 times 2 so here we have what? 2 what? Gram. Do you see that? So the next thing you want to do here is use your normal stuff here. Now they asked us what the mass of what H2 and they gave us and we have calculated what the mass of what HCl. Do you understand? So it's going to be mass to mass what relationship. You get so it's going to be now what is the mass of HCl in this point here is what 73 gram, right? And what is mass of what H is what is 2 gram. So it's going to be what it means that 73 gram of what HCl is equals to what 2 gram of what H2. Do you understand? That is it. 73 gram of what HCl equals to 2 gram of what H2. That is it. Do you understand? So now remember, my mass of HCl is what 109.5. So it's going to be 109.5 gram of what HCl equals to. Now here we are looking for what mass of what H2. So it's going to be S gram of what H2. Do you understand? Find out this guy will cancel out this one here, and this one will cancel out this one here. What are you left with? You are left with what 73 over what 109.5 equals to what 2 over what x. So when you cross multiply here, what do you have? You have x equals to 2 times 109.5 over what 73, right? So what are you going to get? 2 times 109.5 divided by what 73. So here we have 3. Here we have 3. Do we have 3 here? Oh, there's no 3 at this point. So let's do it again. So we have 2 times 109.5 equals to divided by 73. Here we have what 3 what gram. I believe there's something missing here. There's something missing at this point. Is that we miss? Either here should be 5,000 or something here, but our calculation is okay. Do you understand? Our calculation is what it's okay. So I don't have time to start going back again to start figuring out the problem. So you see that what we make little issue what with the question or but the calculation we are okay. Do you understand? So please how to solve problem on when you have something like this. Like what I told you here, chemistry calculation is not like math and physics what calculation. Chemistry calculation is a little bit technical and trickish compared to any other calculation in science. Do you get it? So that is the reason why so lot of students have issues with what chemistry calculation. I myself have issues with chemistry calculation till I started studying chemistry all the time. I started studying chemistry all the time. Start going to past question, beginning getting textbook and try to understand the concept. I also watch videos like this. So as you're watching me here, I've watched tons of videos like this that help me to improve what my knowledge is in chemistry. So please, if you still have issues with this method here, you can also leave it at the comment section that you do not actually get this method very well. But I believe I've solved tons of questions you get that will be of help to you. Like if you don't understand the first question, you're able to understand the second question. If you don't understand the second question, you're able to understand the third question to this point. Do you understand? So I believe I've done my possible best. But if you don't still understand, you can also leave a comment section that you don't understand. But if you understand, only leave a comment section that you understand and you enjoy this video. Please, you can share this video to your friends and to other persons that are preparing for JAMB examination and they are writing what chemistry. Yeah. So like when I said, this calculation is one of the most difficult calculation when it comes to what chemistry, reacting what masses. A lot of students actually have issues with it. And you only see table that can clearly explain to you step by step enough for you to understand. So there are many methods, but this is the method I know and it's more easier to use in what calculating something like this. Just that because the blueprint you don't get once you use on here, you know that you're going to get your answer. So we still have tons of videos. If you know that you still have issues with any of these videos displayed on the screen, any of these topics displayed on the screen, you can go check out this video. Thanks for watching. See you in next video.